A very good afternoon to everybody, and thank you so much for joining us today. We're really excited to be delivering our session titled Enhancing Drone Operations with Simulation. So without further ado, I'm going to dive straight into the agenda for today's webinar. My name is Keegan Schiff. I'll be hosting today's webinar. I'm joined today by our main speaker and company CEO, Alex Verheyst-Erfeldt. He will be diving into and also demonstrating AirborneSIM. Running through the agenda, we would like to cover the entire topic as well as the demonstration in 45 minutes, leaving a bit of time for questions and answers at the end. Starting off, Alex will give us the introduction about the company. He'll then dive into an overview about AirborneSIM. He'll then go in to discuss the complex planning of missions, as well as mission validation and testing, and then finish off with the impact of simulations. So without further ado, I'm going to hand over to Alex and we can commence. Thank you very much.
Thank you, Keegan, for the great introduction. Welcome everyone also from my side. It's great to see you again here. It's the second webinar we have on this topic. And yeah, so before we go into the actual topic, I would like to say a few words about the company and the background. So the origins are from Austria, that's AirSec Systems, and Airborne Robotics from the UK. The companies were both founded in 2017. Nowadays we focus on more than drone hardware. It's really drone autonomy and drone AI, and on sectors with scale. We have set out on the right side a few of those sectors, mainly in the energy sector, so wind, solar, power, oil and gas, power distribution and oil and gas, but also other sectors like our original sectors like surveying, logistics, agriculture, forestry, and last but not least, task forces. We have won several innovation awards over the last years. Here are two samples. One is from the Innovate UK. This was a collaborative project, drone swarms for unmanned inspection of wind turbines. And it basically started off our focus on offshore wind turbines and autonomy around that. The second one we mentioned here is Project Falcon, which won the Innovation Award in the Middle East. I think it was 2023 in Dubai. It's a development project with our partners at Aramco. So this is a brief overview of our product portfolio around the serial product of currently 4 drones. Starting from the left, the Air 4 Nano, which is our smallest, the Air 4 Micro, Air 4 Rugged, which is our inspection and also monitoring drone, and the Air 8, which is our flagship drone. It can lift up to 10 kilos. So it's really, I would say, the maximum you can get out of a drone in the category of below 25 kilograms. They are for inspection, monitoring, and surveying. And then there is certain services around it. I just want to mention here simulation, because that's the topic of today, which is basically embedded around our hardware. We have mentioned our sectors, and here are some of the projects we are currently working on, 2 in the wind sector, 2 in solar, oil and gas, agriculture and forestry, and also logistics. We have got 4 development projects here. Why is that so important? Because simulations, I would say, are mostly feasible and important for complex operations, and also beyond visual line of sight operations, which you find in logistics. And here we have got 2 urban and 2 alpine projects, which we have listed here. So going into AirborneSIM, this is the landing page for our software. You can see here currently 4 environments. Over time, we will build up more of them. Currently, we have offshore starting from a vessel, offshore starting from a substation, the alpine environment, and then the urban environment. Today in the webinar, we will focus on the urban environment. I think that's the, let's say, environment which gives you most of the features that are required from a simulation. Our AirborneSIM, what is it? It is a professional working tool. It's also a technical and operational digital twin of the drone and also the drone operations. It can be used for mission planning, validation, and testing. But not only that, it can also be used as a customer and stakeholder demonstration tool. So it's more than an animation. It's a simulation. So it's a real digital twin of all the systems and all the performance of the drone. But it's also a risk management tool. That means we and our customers can use it in order to manage the risk around operations. It's not a general flight simulator. So a general flight simulator would be unrelated to the actual drone, the underlying drone. No, here it is. It is really the digital twin of our Air 8. So today, when we jump into the simulator and showcase some practical examples, it's our real Air 8 drone which we're using. It is also not a video game, and it's also not a static environment. So it's dynamic. You can place the drone anywhere in the world. You can fly in, from here, from Klagenfurt, from our office, or from London. You can fly in Dubai. You can fly in New York or wherever you want. So it's a dynamic environment. The impact of simulation, we believe, is enormous. It brings the operations to a next level. In particular, and I've mentioned that already, missions become more complex, involve beyond visual line of sight flying, and different levels of risk mitigation which are required. So with the simulation, you can reduce time and cost of real tests. Think of, for example, precision landing. So if precision landing is developed or tested, you don't have to go out and test it multiple times. You can do it basically on your desktop and then go out and only do the final test there. The same for offshore wind. You cannot just choose one day, I want to go out in a wind farm. Going out into an offshore wind farm requires long preparations and planning and permissions, etc. So you basically have probably one shot. So you need to prepare really good when you are prepare on your desktop, and you can do that with simulations. Remote accessibility, again, I've mentioned that before. You can fly anywhere in the world from anywhere, and it gives you a very good feeling of what it means to control a drone from a control center. It's basically exactly the same operations as we do it when we're here on the simulator, but in a synthetic environment. You can do testing, training, train your pilots and also your operators in a controlled and scalable environment here, improve their skills. They can sit on the simulator and train their skills. So that's the perfect training tool, which, by the way, we figured out only as a side effect, because the original idea for building up a simulator was more for the technical development and basically for showcasing to customers. It's also a safe platform for new scenario strategies and technology before deploying them in the real world. Again, risk control and risk mitigation is here the topic. But it's also a development tool. So we use it in-house as development tool, using the synthetic data for enhancement. Again, if you, for example, think of developing strategies in the SATCOM 4G, 5G environment, you can use the data which is derived from simulated flights in that enhancement strategies. We are at the end of the present, and we can now move to the practical part. I'm gonna move to another desk here where I've got the screen with the simulator, and we'll continue from there. Before I start the flight, what you see here, I'm gonna drag this a bit bigger. you have here a pre-planned flight in a typical flight planning tool, which some of you might be familiar. So this is Q-ground control. There are others, but this is just an example. So flights can be planned in your planning tool of choice. And this is typically a waypoint planning. And just to give you here some, kind of how it looks like. So you put in the waypoints. Those are reflected here on the map, and you have here got a height diagram of what that means in terms of are you colliding with the actual surface. So here you can see that we are getting very close to the surface because we are flying up a mountain, and then we fly back again, and then we go through the urban kind of environment. And that's why Klagenfurt is a relatively good use case, because we're starting off, we're going up a mountain, coming back, and then being in the urban environment, which is perfect. So these are, we could go through the details here. I won't do that, but what I will do, I will go probably, let's upload this, and I will go back to the flight mission. So now that we have uploaded the flight, we would be able to start that. And let me just make this a bit smaller so they can actually see. So we want to see both. We want to see where the drone is in the overall environment, and we want to see it here flying in the 3D environment. Okay, so why don't we start this? So we've just armed the drone. I'm going now to third person. And so if the quality is not 100% perfect, I have to apologize. That's probably due to connection issues in the webinar or kind of restrictions of it. Certainly much better on my screen. And we are having a lot of data here. So there might be a little bit of rendering involved. So if it kind of clears up only after some time, then that's probably the reason. What you see here, we are flying what we have planned here in a 3D environment, and the typical thing that you have here is the planning tool is so we plan here, we upload it to the drone. That's what we typically would do, and in our case, we have uploaded it to the simulator, and we're flying it in the simulated environment. So everything is exactly like it is with the real drone, but in our case here, we're not flying with the real drone, we're flying with the simulator. And so we are getting here now very close to the mountain ridge. So that would be a typical, let's say, test we would do on the simulator. When we plan a mission, then we would like to kind of test it if our planning is good enough, or if we have probably have to optimize it, or if we have even misplanned it so that we have to redo it. But in this case, everything worked out well. So we're going down again the mountain towards the city center, and this is quite a stretch now, but we're flying with 35 meters per second, so we're going to be flying quite fast actually here. Yeah. So on the left side, maybe I should mention it here, some of the telemetry data, distance to home, flight duration, and that's all the real data, horizontal speed, vertical speed, altitude. So we are relative to the starting point 250 meters above ground. That's typically not what is allowed in an open category flight. So if you would take that kind of flight height, you would have to ask for specific permissions to do that, battery levels, starting location, and so on. And then we have on this side here, we have currently we're in third-person view. I will swap to first-person view once we reach the city center. And here we have also the gimbal control. We can basically move the gimbal. Again, I will do that once we are in first-person view. So next waypoint here is waypoint number 7, which is right in the center.
And Alex, I noticed you're using the Air8 platform here. Is it possible to use other platforms from Essex Systems or other platforms outside of the company as well?
Yes, sure. So we have currently 2 platforms in the simulator. We will probably add a third one over the next weeks or so. The reason why we're using here the Air8, it's our biggest platform. It's in the simulation environment. It's the most significant one. So let me just stop here for a second. So it's the most significant one, and it's the most visible one here in the simulator. They all behave quite similar, although I have to say this is an octocopter, the others are quadcopter, so there is a little bit of difference to it. But for us, we will add also the Air 4, which is the second biggest one. But in terms of the color, and so this is really the best one to demonstrate. So I've just stopped the drone, and I will now take over manually. So this is just to showcase that you can, first of all, practice here manual flying. It's very close to the real behavior of the drone, and it gives you a really good feeling what it means when you switch between manual flying and auto flying. And what is also great in a simulator like this, you can try out stuff you would never try out on the real drone, because for obvious reasons you don't want to mess around with the real thing. But here you can really try everything. You can go very close to structures and really can improve your skills. And I'm not a pilot, so for me, all I know is just from the simulator. So and that's a great thing. You can really do it anywhere in the world. You can test anything. You can max out the speed, and you have so many functions. So if I just loiter is one of them. So you have a lot of functions that can go to details. And those are the things you probably would never do on the real thing, but can try out here. So now I have to be careful because I want to go to the next waypoint. So here, as you can see, it's the same with the real drone. If you're in the supported function of loiter, so it's the supported manual flying, the drone would not drop off the air. It just stays and hovers on point. So I would now go and continue with the next waypoint. That one is the green one, which is number 7. And the drone now has reached waypoint number 7. So I've stopped just before it and would then go from the next waypoint towards the lake.
Now, Alex, I noticed you showing us the drone in third-person view. Is it possible to have the same view as the actual drone would have?
Yeah, so I forgot that actually. Should have shown it to you in the manual flight mode. So you can see here I'm moving the gimbal, and this is more or less the view you would have when you fly the drone. Now I should probably show it to you in the other case, because when we fly very fast and with the rendering, might make you a little bit dizzy, but so again, you can switch between first person and third person view, and here you've got a target to kind of see where you are. Yeah? So we are making our way towards the lake, and all the distances, all the time involved, that's all as close as it gets to the real thing. So it's a perfect tool to kind of fly through your mission before you really go out and see and do it in real, so that you can check is that mission feasible with regards to my battery level and so on.
And now, Alex, I noticed you're flying with one drone. Would it be possible to have more than one drone in the simulator at a given point?
Would be. We have it in the offshore wind strategy, so we are flying with 4 drones. What it just means, it means you have to have enough processing power, kind of would multiply the amount required. So yes, it's possible. Right now I'm flying on it's a laptop, has to have a decent graphics card, but it's nothing special. So what is required is really standard. So I'm gonna stop here briefly, and this mission would go on for a few minutes. So I'm gonna swap to the next use case we have prepared, and just to change the scenery, but I think that's all we wanted to show here on this Klagenfurt flight. In that case, I will just close this down and will also exit here. And we've prepared a second one. We're picking the London one, not the LA. So again, the same kind of landing page here. So we always start from our S6 container. Giving it a few seconds to build up.
So I do have a question for you, Alex. In terms of the realism, in terms of the environment, is it possible to update or refine these assets so that they look maybe a little bit more realistic, or is there a reason why they're not hyper realistic at the moment, like your container is?
Yes. So let me slide this out first. So this is the typical start. We slide out. With the slide out, we open also our mission planning tool. And again, this is 2D, whereas the simulator 3D. So we have a relatively realistic, well, a very realistic kind of environment, and specific assets we can just customize. For example, this container or whatever is required, we can customize it. What is not already there in the natural environment. I'm just gonna briefly open up the mission. London, there we go. So again, we have the container. That one is placed already. This is it's quite a known and a big hospital here in London, St. Thomas Hospital. which is just south of the river. And we're going to make or simulate, let's say, an emergency delivery, in this case to Buckingham Palace. So we will simulate a drop-off there and then fly back. This is just a randomly chosen route. We will also check what that route means for us in terms of what buildings, and have we planned it well, and we will probably optimize in case we find something which doesn't look right. And so to showcase a little bit that this is a good tool to kind of adjust and optimize routes. So again, here we upload it, in this case, to the simulation drone, not to the real one. And we should be ready here to take off again. This is exactly the same what you would do once you are flying with the real drone. Again, we have a little bit of rendering delay here, but we're flying here towards Big Ben, and hopefully it's not a Big Bang. So we're going very close to the tower here, and then we will head towards Buckingham Palace here. So in real flying, you would make a risk-adjusted path planning. So you would probably try to fly as much as possible you can over closed buildings. So in case there is some problems, you can limit the ground risk. But here this looks quite good. So you will see once we approach, the level of details you have here is already very good. And I'm going to prepare, just in case I want to stop. So if you haven't been at the Buckingham Palace, haven't been invited for the barbecue, then this is probably as close as it gets for you to Buckingham Palace. So this is the simulated drop-off. Now the drone would either have a winch and upsail the emergency item, or it would just go down. And now let's see how this was planned. This gets a little bit exciting here. Relatively close. Okay. Wow, this is very close. So in this case, let's so if I would plan now the mission, I would probably now go back and kind of redo that. That's probably a little bit too dangerous. Just 1 second. So I'm flying here manually back. So it's a bit laggy today. Let me just adjust this.
Alex, will we be able to see this in first-person view as you wanted to show us?
I'm sorry again. I should do this. Yeah. So again, we have here you can here really go into detail. I mean, play around a bit, But what I wanted to do is also something else, which is basically showing you how I would correct this. You have seen we came very close to this. It was basically around here. So what we want to do, we want to replan that. Let me just, so this would be, we would probably adjust this point already. So let's say go up to 20 here.
So there you're adjusting the height, is that correct?
Yes, I'm adjusting the height, and there I would probably go at least to 38. Yeah. And so what we would have to do, we upload that again, and I'll put this here, and then what we would do, we would now go back to auto, and so we have adjusted those two waypoints so that hopefully we will be at a higher distance to what we have just planned beforehand. So let's see if we are actually flying higher. It's still relatively close, but it looks better, I think, than it was beforehand. So we could have maybe even gone up 5 meters more, but obviously it was good enough. So what would happen if we would crash? It would really crash the drone. And we have put in a little bit of a, let's say, so it would crash the program. You would have to go out and come in again. So this is a little bit of a burden for you in order not to crash it all the time. So you really want to plan your missions properly. And now we are flying back towards the starting point. And again, would be the same with the real drone. The drone would automatically move back to the starting point. You don't have to do anything. It's all done automatically by the drone. The only difference here is you would probably not fly as fast. You would probably fly a little bit less fast than that. The drone is now setting down again for landing. The descent speed is typically around 2 meters per second. Yeah. And those are the things which you can also here practice and really train is the precision landing. So we are back where we started in this mission. This is it for the practical part. Keegan, do we have any questions? Any more questions?
Yes, so we do have a question here. Are you able to model adverse events to troubleshoot activity?
Yeah, I think this goes a little bit in direction, for example, the effects of weather or adverse events. I could think of, for example, bird collision. Yeah. So this will be something we will do in the future. Adverse events, in a sense that colliding with a building, that's already in there. Bird strike, etc. We have not yet, because we haven't included any birds. Or colliding with another drone would already now be included, but colliding with another drone would mean the loss of the drone. So if we would go into that much detail, what it means if we lose one rotor, for example, that's probably something for the future. Yeah, we can think of, definitely. Any other questions, Keegan?
Yeah, so this question has come up twice. I think the overall question is there the opportunity or the ability to add different weather parameters within the simulation?
Yes, so definitely this is going to be something which will come in the future, and it can, in theory, even go as far that we can simulate live weather. So we are currently building up a simulator which is actually mandated from the European Space Agency, from ESA, where we simulate the SATCOM performance. Why is this important? Because at the moment, the typical flights we would do is with remote, so with direct radio. But if you fly beyond visual line of sight, then you would fly with SATCOM or 4G, 5G. And building up the simulation of that SATCOM performance is an entire work package by itself, and it will be then probably plugged into our simulator. And for SATCOM performance, weather, for example, is very important. So weather for the SATCOM performance, but also weather for the drone performance. What does it mean? What means rain? What means headwind, and so on. So all these things, they will over time be implemented in this simulator to make it as realistic as possible. Definitely, yeah.
Okay. And then another question, in terms of the regulations, we noticed that you are flying sometimes above 120 meters. Does the simulation itself take regulation into account, or is it something that you need to set manually and adjust as required?
So at the moment, it's not taken into account because the simulator needs to give you as much as possible opportunities to do things which you want to develop for the future and which might not be allowed. But we will also include regulatory items. So we haven't mentioned that, but one of our projects is Drone Uber, or Dr. Uber, which is basically a network of drones for emergency drone deliveries. And here we have already included basically some of the regulatory features, some of the non-flight zones or flight restricted zones. So this will be also elaborated and amended over time and will be included. It's for sure, the more complex the flights are, the more beyond visual line of flights we have, the more important this will become. And then we have in the 3D environment also so flight restricted zones included, and also components of regulatory restrictions. But for now, this is as open as it gets. Yeah.
Okay. I think we have gotten through the majority of them. And I think that leads us to the end of the session. So from my side, Alex, thank you very much for the demonstration and also for the insightful insights into the use of simulation in drones. I think it's an exciting space and I think a good start point for the drone industry in general. So thank you very much for delivering that. And also thank you to all those that took the time to join us this afternoon. It was great to see a keen interest from our previous session and again from the session as well. So thank you very much. If there are any additional questions, there is a contact details currently on the screen. Feel free to drop us an email if you do have any questions on simulation. And look forward to seeing you in the future for some of our future sessions. I have seen thank yous coming in as well from some of the attendees. So thank you all for attending. And last comments from Alex, I'll hand back over to you before we close off for the day.
Keegan, thanks for moderating this, and thank you everyone for joining us. It was a pleasure to give you a short snapshot of our simulator. The real thing is, of course, always better, but no, we enjoy over time to also improve and and present you more and more, and hope you will be joining us again in the future. Thank you. Bye-bye.